Okay, so let's discuss some of the double angle theorems that you're going to need to know. Right, first one is this one. Sine two lots of an angle is the same as doing 2 sine of that angle times cos of the same angle. Right, okay, now let's actually discuss what that means really. Okay, so let's look at this. If I did sine of 2 times 50, or sine of that's effectively 100, isn't it? Sine of 100 degrees. Okay, let's stick to degrees for now. And let me just work that out. So, and let me clear all this stuff. Okay, so sine of, I'll actually type in 2 lots of 50 in here. Okay, no, I'll tell you what. Let's put 100. Well, what do we get? We've got 0.9848. Okay, that comes to 0.9848. I'm sorry, yep, 9848. Okay, now what that's saying is this is saying if you do something like this, which is effectively doing that, then it's the same as doing the following. It's the same as doing this. If you actually did 2 times sine of, what angle did we actually double? We doubled 50, didn't we? So if we did 2 lots of sine 50 times cosine, cosine 50, it's the same thing. So let's actually check that out on the calculator. Do we get the same answer here? So if we do 2 times sine 50 times cos 50, do we get the same thing? So 2 times sine 50, push across. Okay, can you see the bracket opening up here? We need to push across, times cos 50, press enter. Yep, we get the same number. So with the same number. Okay, so we get 0.9848 roughly. Okay, they're identical to each other. So this is a theorem that you need to remember, that sine double of an angle equals 2 sine theta times cos theta. And now I'm not going to discuss where this particular rule comes from in the proof. I'm going to post another clip for you to have a look at so you can sort of investigate it for yourself. But it's something that you should just remember. Okay, now the next theorem. Now this is a funny one because there's sort of 3 different ways to write this particular one, and it's to do with the cosine now. So cosine double an angle, cosine of double of an angle is the same as doing cos squared theta take away sine squared theta. That's one way of writing it. So let's just do an example here. So for example, let's stick to the same angle we chose here. So let's work out cos of 2 lots of 50. Okay, cos of 100, and see what that number is. So cos of 2 lots of 50 is 100. What do we get? Minus 0.1736. Minus 0.1736. Okay, now let's actually do this. Let's remember what this is. Cos squared theta. That's cos, okay, 50 squared take away sine 50 squared. Okay, that's effectively what that is. So let's work that out and see if we get the same number. We should do, because it's a theorem, right? So, oh, hang on. No, I need a bracket first. Cos 50, push across, squared, take away, open bracket, sine 50, push across, squared, press enter. What do we get? We get the same number, yep. So we get the same number, minus 0.1736. They're identical. Right, but the funny thing about this particular rule is there's 3 different ways to write it. You could write it this way, or using one of our identities from earlier. If you remember, cos squared theta plus sine squared theta equals 1. Remember the triangle? And using Pythagoras' theorem, we get this equals 1. Well, right, first of all, let's look at writing this a different way. I'm going to actually replace this sine squared theta with this. Now, rearranging this, I can take that cos squared theta to the other side, right? So I'd have this, sine squared theta equals 1 minus cos squared theta, right? I'm just subtracting it to the other side, right? Now I'm going to take, you see, I've got sine squared theta here, and I've got sine squared theta here, which also equals this. I'm going to replace this with all of this and then simplify, right? So I'm going to have cos 2 theta equals cos squared theta minus, and I'm going to put this in a bracket for now. I'm going to have 1 take away, and what is it, cos squared theta. Okay, now I'm just going to get rid of that bracket by, well, effectively I've got minus 1 here, and I'm going to times each one of these by minus 1, so I'm going to have cos squared theta take away 1, and then this is going to turn to a plus cos squared theta, so we have this, that cos 2 theta is the same as, well, okay, well, we've got 1 cos squared theta and another one, 2 cos squared theta take away 1. Okay, there's the extra way of writing it, if you want to think about it, the alternative way to write the same theorem. And let's just check that works as well. So let me continue the squiggle. Cos of 2 lots of 50, or we already know that was minus 0.1736. Alright, now let's do this. 2 times cos 50 squared, take away 1, and see if we get the same number. We should do. Okay, that's the number we're aiming for, this one here. So let's do that. 2 times bracket trig button cos 50, push all the way across, squared, push across a bit more, take away 1. Press enter, and lo and behold, we get the same number. So that works as well. So we get the same number. Right, that's one way. Now, using the same identity, this one here, that cos squared theta plus sine squared theta add equals 1, I'm just going to rewrite this a second way now. Let me copy out in blue. Cos 2 theta equals cos squared theta minus sine squared theta. Now, okay, now, using the same identity, I can take the sine squared theta to the other side, right? Take it to the other side. So I have that cos squared theta equals 1 minus sine squared theta, right? Okay, just taking that one to the other side. So I've got a cos squared theta here, and I've got a cos squared theta here, which equals this. So what I'm going to do is I'm going to replace this with all of this, because I can, because it's saying this equals this, right? So I'm going to replace that. So I'm going to rewrite that as 1 minus sine squared theta, and then I'm going to take away this one. I'm going to bring that down, sine squared theta, right? Now, let's simplify that. I've got 1 take away sine squared theta, take away another one, so I've got to take away 2 sine squared theta. That's right, that's the third way to write the same rule. Okay, and let's just check that right. Okay, continue that squiggle, let's check that works. So cos of 2 lots of 50 we know is minus 0.1736. Right, so let's just check this. 1 take away 2 lots of sine 50 squared equals the same number. Okay, let's just double check that. Okay, so we're aiming for that same number. So we're going to do 1 take away 2 times open bracket trig button sine 50, push all the way across, squared. What do we get? We get the same number. So there's the, okay, so there's a proof. There's 1736. They work as well. Right, so summing up those rules, okay, so let's just underline it. The ones to remember, okay, so remember the following. 1, sine double an angle equals 2 sine of the angle times cos of the angle. Okay, and then the second one, okay, I'm going to do it in different colours now. Okay, so the second one is that, oh, let me scroll down, the button's not working, it's a bit temperamental. Cos 2 theta equals cos squared theta take away sine squared theta. Okay, so cos double of an angle is cos squared of the angle, take away sine squared of the angle. But I can write it like this as well. So 2 cos squared theta take away 1 will do the same job. Or, third and final one, 1 take away 2 sine squared theta. Okay, there are 3 ways to write the same rule. Isn't that confusing? But that's maths in general, really, and that's why I love it.